All right, good afternoon, good evening, ladies and gentlemen. Finally going to start our trigonometry. I know I say this a lot, but this is some of my favorite stuff to do. Getting to solve some triangles eventually, looking at all of our trigonometry identities, our theorems, I know you're not going to like this word, but our proofs. All right, so this gets pretty fun, gets pretty interesting. We have now left our study of our algebra. We are basically going to start a whole new language for almost every single one of you out there. All right, so this is going to get challenging, but as long as you guys kind of bear with it and kind of learn along the way, we'll all make it through to the end. All right, so we got trig all the way until the semester break. All right, so the first thing we need to start talking about is the idea of an angle. And this is actually a angle here. You might not have seen these very often before, but this is DMS. And this stands for, if you don't know this, it stands for degrees, minutes, and seconds. So DMS stands for degrees, minutes, and seconds. And this is quote unquote the normal way to measure an angle. And well, the normal way is to measure in degrees. We're going to get into the trig way to measure angles in a little bit. All right, so a degree is 1/180th of a straight angle. And you should know that because a straight angle has an angle measure of 180, so 180 degrees. So this is 1/180th of a straight angle. A minute is just like you would think of as on a clock. It's 1/60th of a degree. And likewise, a second is just as you would think. A second is 1/60th of a minute. Or if you're going to go straight to degrees, it's 1/3600ths of a degree. So it's 1/60th of a 1/60th. All right, and 1/60 times 1/60 is 1/3600. This is used in navigation all the time. We talk about bearing using navigation either with a boat or a plane or anything else like that, or a rocket. Everything uses bearing. All right, and what we need to really, it's very important that we understand this this statement that I'm going to make here. Bearing is measured clockwise from due north. All right, so what that means is if you're looking at a map or something like this, this looks like a coordinate grid, but I hope you know that this is north, east, south, and, hopefully I say west here. Okay, north, east, south, west. Never eat shredded wheat. Bearing is measured from the north in a clockwise direction. All right, so this angle right here would be a bearing measure. And I'm stressing this because there's other ways that we measure angles when we get to those type of things coming up. All right. So what I want to do now is I want to be able to convert between degrees, minutes, and seconds and what a degree looks like as a decimal. The reason I want decimals is because the decimal works better in our calculator. Even though technically we can use DMS in our calculator, it's just easier to use decimals rather than the DMS. All right, so first of all, we're going to take this particular decimal degree and change it to DMS. So you should, I would hope, you could look at this and go, oh, this is 37 degrees, some minutes, and possibly some seconds. And the reason I know it's 37 degrees is because it says it's 37 degrees and a little bit more, right? So we're going to use some of the conversions here that we were just looking at, and we're going to look at the decimal part to find the minutes. Well, this 0.425 is part of a minute, and it's actually 0.425 parts of a minute. So we're going to say it's 0.425 times 60. How much of 1 minute is this particular decimal? And if you do that, 0.425 times 60, you get 25.5. Which means I have 25.5 minutes, which means this 0.5 is now part of a second. So we're going to use the next decimal part to find the seconds. And most of you could probably do this in your head. You already probably know. If I did 0.5 times a part of a minute, I get 30. So this tells me that 37.425 degrees is the same thing as 37 degrees, 25 minutes, and 30 seconds. And this is helpful in the real world, okay? You don't always hear the decimal versions in the real world. You hear a lot of the bearing versions or the DMSs in the real world. All right, so that's kind of all you have to do. You take the decimal, multiply by 60, take the remaining decimal, multiply by 60, and you can get your minutes and your seconds. All right, so let's go the other direction. Let's take this DMS and go back to decimals. And like I said, it's easier for your calculator to use decimals than it is degree. MS, okay, DMS. All right, so I know that it's 42 degrees and some part of a degree. Well, it's 24 out of 60. So it's 24 out of a total of 60 for 1 minute, or for 1 degree. Plus 36 over, now here's where you be careful. It's not over 60. It's over 3,600 because I want to go straight to degrees. I'm not changing this minute. I'm not changing the minutes, or sorry, the seconds. I'm not changing the seconds into minutes. I'm changing the seconds into degrees, so I want 3,600. And that's actually it. Now it's just plug it in your calculator. And I get 42.41 degrees. And that's actually it. And this is actually kind of useful to know, being able to convert back and forth. All right, let's go ahead and move forward here. I want to be able to add. I want you guys to be able to add and subtract degrees, minutes, and seconds. And we need to remember how to carry and borrow. So what I want to do here is I want to take 24 degrees, 15 minutes, and 49 seconds, and I want to add it to 12 degrees, 51 minutes, and 13 seconds. Now, the reason, and now this is carrying because this is addition, right? The reason I want to make sure we understand carrying is because if I did 49 plus 13, I get 62. But there's the problem. There's 60 seconds in 1 minute, which means we've gone over the number of seconds, which means we've gone over and we need to start carrying. So I'm going to get rid of that. I'm going to say, okay, well, that means 62 comes down as a 2 seconds. It's actually 1 minute and 2 seconds, right? So I'm going to carry the 1 up to the minutes and drop down the 2. Then I could do the same thing. And you got to remember that there's 60 minutes to a degree. So 15 and 51 make a 66, plus 1 makes 67 minutes. But the problem is there's 60 minutes to a degree. So there's a leftover 7, and I have 1 extra minute. And then I can do 24 and 12 make 36. 1 makes 37 degrees. All right, so it's all about carrying, and we just had an extra minute. We had an extra degree in order to carry. But what if I wanted to subtract those two numbers? Let's say I did 24 degrees, 15 minutes, 49 seconds. This is like finding the distance between 2 points on a graph or on a globe. You can know their degrees, minutes, and seconds, and you could subtract, finding the distance between. All right, so now I want to subtract. Well, I can do 49 minus 13 with no problem. I get, what is that, 36 seconds. Now here's the problem. 15 minus 51 would come out negative. So I need to borrow. I need to borrow 1 minute. Or sorry, 1 degree. I need to borrow 1 degree. And 1 degree is worth 60 minutes. So this becomes a 75. So I had 15 and 60 more. Now I can subtract to 24 minutes. And then this one, the straight down, this is, let's see if I can do this correctly, 11 degrees. All right, so it's all about carrying and borrowing the right number of units. All right, this is pretty interesting, but this is used a little bit more often because you're going to be given two areas on a graph that are on a, not a graph, I keep saying graph, on a map that are directly north of one another, and you could figure out distances from those. All right, now we are getting into big time trig. And you might be chuckling right now, but this is big right here. Radian measure. There are two different ways to measure angles. And now that you're in trig, we are basically going to do almost everything in radian measure. We still do degrees, but a lot of it's going to be radian. And when you get into calculus, it's almost, actually, I think all of it is radian measure. We rarely ever use degrees anymore. You get into higher level math, we just start using radians all the time. Why, I don't know. I really don't. But we do. It actually works a lot better than decimals. So, what radian measure is? You guys understand that a degree is 1/180th of a straight angle. Well, it's not the case for a radian measure. A radian measure is a central angle of a circle has measure 1 radian. So now we're looking at the angle. If it intercepts an arc with the same length. Okay, so let's see how bad I can draw a circle here. So I'm going to draw a circle. And a central angle. This right here, we're going to start calling these things theta, by the way, these angles. This is angle theta. By the way, theta is the Greek letter. It looks like this. It's a circle with a line through the middle. Okay, I will draw it sometimes like this, but they're the same thing. This angle is 1 radian as long as this arc is the same length as this radius. Central angle meaning coming from the center, right? So if this radius is the same thing as, or sorry, if this arc is the same length as this radius, then the angle has a measure of 1 radian. So the question then asks, how many radians are in a whole circle? So you could think, okay, if I have this radius, and I come out here and I get an R, and then I get an R, how many radian measures, how many angles am I going to get in here that are all the same of 1 radian? Am I going to get 6? Am I going to get 10? Am I going to get 5? I hope you're trying to think about this question in your head right now, or even shouting it out, making the people around you think you're weird. Okay? Well, what you can kind of look at is this is a radius, trying to wrap the radius around a circle. Well, that's old school. That's like old school geometry. That's just the circumference of my circle. The circumference of my circle is 2 pi. It's gonna get around almost 6 times. It's gonna get around almost 6 times with a little bit extra, right? So it's like 6.28. Okay, so there are, and this is very important that we understand this, super, super important. There are 2 pi radians in a whole circle. I'm just letting that soak in. There are 2 pi radians in a whole circle. So this number pi is so important in the study of radian measures, study of trigonometry. And something that we will basically use daily for the rest of our times in trigonometry is how many radians are in a straight angle. Well, since a straight angle is half of the circle, I hope it leads you to understand that there are pi radians in a straight angle. So if you have a straight angle like this, straight angle, the radian measure is pi radians. But the other reason this is super important for us is now we can compare radians to degrees, because we know that this also is 180 degrees. And that right there is what I'm actually going to be getting into. This is our conversion factor. I know that pi radians is the same thing as 180 degrees, so I can convert between the 2 different angles, or 2 different types of measures. So here's a little question for us. If I wanted to know what is 1 radian, 1 radian is not 1 degree. 1 degree is not 1 radian. We'll come back to this in a few minutes once we figure out how to do some conversions. And I want us to make sure we understand this particular statement. So we're going to use that conversion factor in order to convert between radians and degrees. Now, if I wanted to go from degrees, so if I had x degrees and I wanted to multiply by something to get it equal to some radians, I would need a ratio that would cancel degrees. So I need to cancel degrees. Some of you guys might remember this from chemistry if you've taken this. Some people call it boxcars, dimensional analysis, basically. Okay, but notice I need to cancel degrees, which means I need radians in the top. And we know from that last slide that pi radians is 180 degrees. So in order to go from, oops, I did it backwards. Oh, if I want to convert, I did the wrong one first. It's all right. This pi, or 180 over pi, is to go from, let me do it a little erasing here. That's what I get for not paying attention. All right. 180 over pi is to go from, darn it, radians to degrees. The pi over 180, as I just mentioned a second ago, is to go from degrees to radians. And this is super, super important that you understand, and you basically memorize these 2 statements. A lot of this first stuff that we're dealing with in this chapter just basically needs to be memorized. It just does. So the question here, sorry about writing there, I want to know how many radians are in 90 degrees. Oops. Well, I can change 90 degrees into radians by taking 90 times pi over 180, and do not multiply by pi, and do not get decimals here. We really like the fractions. If you did 90 times pi over 180, the degrees cancel, I'm left with radians, is equal to pi over 2. Now, most of you probably could have realized that, because if 180 equals 1 pi, 90 equals half a pi. What if I wanted to go the other direction, go from radians to degrees? All right, so I'm going to use the other conversion factor. I'm going to multiply by 180 over pi. So I can say pi over 3 times 180 over pi. Most of you could probably do this in your head. And I get 180 over 3, which is 60 degrees. And you could have probably thought about this as well. If pi is really 180, this is just a third of that 180, which is the 60. Now we're just scratching the surface right now, but this is already I'm already thinking how cool this is going to get in the next few weeks. All right, here's another one of those formulas, little things that you're going to have to memorize and never forget. My calculus kids keep forgetting this formula. We used it right at the beginning of the year. It's one of the simplest formulas we have. S equals R theta. S is what we call our arc length. R is the radius of the circle. And theta is the central angle measure. So we can look at a circle, and let's say we had some radius, and I wanted to know how long is this arc. That's why it's called arc length. This arc is S, and this angle is theta. And it doesn't matter the length of R. We can figure out the length of S. Here's a big thing, though. This formula, the way it's written, is for radians. If you want degrees, you need to convert to radians. So I need to take S equals R theta times, I'm changing degrees to radians, so pi over 180. Okay, slightly different way the formula looks, but same idea. I don't really like this one very much. I just like to make sure we just change theta into radians before we even use the formula. So here's one of those silly little questions that Mr. Nelson likes. Find the perimeter of a 40-degree slice of pizza cut from a 12-inch pizza. So you have a 12-inch pizza. By the way, that means diameter. And you cut out a 40, let's say 40 is right in there, a 40-degree slice, and you want to know the perimeter of your slice of pizza. Well, you need to know how long the crust is, which is S, and basically you're going to need to know R. Well, R is easy because it's just half diameter. All right, so that means the perimeter is equal to R plus S. Well, R is 6, and S, this is degrees, by the way, so we need to actually use this one. We're going to use this one here, the arc length formula. S is arc length, so S is equal to my radius times 40 pi over 180. My degrees times pi over 180. And since we're getting a real world length, here's where we actually get to multiply by pi. So 6 plus 6 plus 6 times 40 pi divided by 180. I get 16.19. Cool, right? Yeah. I know you didn't say it was cool, but I thought it was. It's a nerdy thing that nerds do at pizza shops. They measure the perimeter of their pizza slices. All right? Now, here's your assignment. Here's your due to me. I'll get you guys an assignment sheet tomorrow morning. We are going to start these little things called mini quizzes, by the way. Sorry, that's actually meant to say mini quizzes will actually, we're going to start them tomorrow. I don't know why that said Monday for me. They will start Friday. At the end of the class, I'm going to give you a little, usually 2 or 3 question problem quiz. And in your group, you just want to finish them, give them to me by the end of class. Okay? It's kind of just a little temperature check to see where you guys are at, make sure you guys are on the right track. All right? These are going to become very important when we get into the heavier stuff in our trigonometry. All right? So I hope you guys had fun today. And even if you didn't, I hope you learned a little bit. And I hope you guys have a good evening. Watch the video, do your homework, do any work you want to do. Come see me tomorrow morning.